Welcome to Dr. Raz, the Baking Chemist. This is another request from one of the students. So, Freons, what's all that about? Do I need to know? Do I even care? Let's find out. At the end of the video, I'll have a small request to make. So watch till the end, please. The question is a small amount of the freon, right? Freon, do I care, right? All I need to know really is, no, I don't care what freon is. All I need to know is what the formula is. And I think you need to remember, examiners deliberately put these unfamiliar words, unfamiliar scenarios to confuse, not to confuse, but to test students, okay? They're not going to give you the questions that you found in the textbook or in the past previous exam papers, surely, all right? They're going to test you somehow with new scenarios, okay? So don't be put off with these unfamiliar words. Read the question. Let's read the question and actually find out whether we need to know freons at all. I think you'll find out we don't. Let's do it. So a small amount of the freon, CF3, so they've given us the formula, with a mass of 1.78 times 10 to the minus 4 kilograms escaped from a refrigerator. The first thing I'm going to do is I'm going to highlight this kilogram business, because masses in chemistry are usually, you know, moles, etc. It's in grams, not kilograms, so I might have to do something about that. Escaped from a refrigerator into a room of volume 100 meters cubed. Okay, so that's a meters cubed. Usually in chemistry, volumes are centimeters cubed, so you know that's why I'm underlining this. Assuming that the freon is evenly distributed throughout the air in the room, calculate the number of freon molecules in a volume of 500 centimeters cubed. Can you see there's your centimeters cubed? All right, so obviously I need to be aware of that. Give your answer to the appropriate number of significant figures. All right, so that means in this particular question I have to worry about significant figures. The Avogadro constant, 6.02 times 10 to the 23 moles. Okay, I will tell you, you know, where students go wrong, but I'll tell you later at the end of the video. Right. So Avogadro is a constant, so there must be a reason they're giving us that, right? Okay. So they've given me the formula of freon. So the first thing I need to know is into a mole of, assuming that the freon is okay. So I need to work out the number of freon molecules in 500 centimeters cubed. So if I need to work out number of freon molecules in this centimeters cubed, then that means I probably need to know how many molecules were escaped in the first place. And therefore, I probably need to know, because Avogadro's constant tell us number of molecules per mole, so every 1 mole, I probably need to work out moles of these freons, which shouldn't be a problem because I've got the formula, I've got the mass. All right, then I can work out moles. That will tell me how many molecules in that many moles. Then I'll find out, well, if that many moles of molecules are in 100 meters cubed, how many 500 centimeters cubed? It should be a short video. Let's see. All right. Okay, so first thing I need to do is need to work out the MRF CF3Cl. Okay, so and remember why. I need to work out the moles of freons. Right, and in order to work out moles, I need mass over mR, and therefore I need mR. So mR of CF3Cl, freon, is equal to, and you can work it out yourself. It's 12. Okay, so it's 104.5 chlorine. There isn't it? Must be a 5. 104.5. Okay, so that's mR. Mass, and this is where you need to be careful. All right, remember I said mass is in kilograms, but in this formula mass is actually in grams, so I'm going to change that into grams. All right, so how do I change kilograms into grams? By multiplying it by 1,000. Okay, kilograms into grams, so it will be 1.78 times, I'm going to try and write a little bit bigger actually, because I think you might be able to see it better. But I'll probably start it from the next sentence onwards, times by 1,000. That will give me grams of freons. So that is, well, that's quite simple, isn't it? Times by 10 to the minus 1. Okay, Yeah, I could have written it. This is standard form. I could have written it the other way around, but let's just see. So that is mass. So I should have done mass of in grams. Okay, in grams. And therefore that's in grams. And therefore I'm now going back to that formula, is moles of equals 1.78 times by 10 to the minus 1, and then divided by 104.5, okay, which equals, there's, you know, MR, isn't it, equals, and that is equal to, oops, apologies, calculator's trying to escape, that equals 1.70 times 10 to the minus 3. Now, the calculator shows me lots of numbers. For God's sake, don't start writing lots of numbers here, okay? Yeah, use the appropriate significant figures, and the significant figures that they said that they want us to use they want us to use the appropriate significant figures in the answer, so I might as well start using the appropriate significant figures now. I'll say more about it later, but just for the time being, I'm going to use 3 sig fig. That's the appropriate number of significant figures. Why? Have a look at the question. I'll deal with it in a second, okay? But please don't waste time writing all these numbers. Right, so that's 1.70 times 10 to the minus 3. Okay, so now I got moles. Remember, I'm trying to figure out number of molecules. So the question says, okay, so the number of molecules in this many moles is, so number of molecules equals 1.70 times 10 to the minus 3 times by the Avogadro's number, which is 6.02. It's actually 6.022, but there's a reason why they've said 6.02 times 10 to the 23 per mole. Okay, so the number of molecules of Freon is, multiply that together, and 1.02 times 10 to the 21. Okay, so that's the number of molecules, but that's the number of molecules in what? In 100 meters cubed, right? So therefore, number of molecules in 500 centimeters cubed is equal to, don't know how you do the maths, but anyway, the way I'm going to do it is, if this is how I do it, maybe I should show it to you. So 100 meters cubed molecules, how many molecules in 100 meters cubed? 1.02 times 10 to the 21. Say 1 meters cubed is equal to that divided by 100, which equals 1.02 times 10 to the 19. Okay, you can use a calculator if you like, but that's what it is. And then if one, now the next question is, where people often go wrong, is the conversion. They want it in 500 centimeters cubed. That's what the question is saying. So in 500 centimeters cubed, what you do is you simply say, oh, how many centimeters cubed? So how many centimeters cubed in a meters cubed? I'll explain it here, right? The way you need to sort of realize it is this. Can you see this cube? My rubbish cube, my apologies. Cube, right? In a cube, there are three measurements, okay? There's a height, there's a width, I suppose, and there's a depth. If this is 1 centimeters, this is 1 centimeters, this is 1 centimeters, then all the multiplied centimeters cubed is 1 times 1 times 1. So if I have 1 meters cubed, so how many centimeters in 1 meters? How many centimeters in 1 meters? So in 1 meters, there's 100 centimeters. Sorry, in 1 meters. Okay, but this is 1 meters cubed, so it'll be 100 times by 100 times by 100, and therefore, when you work it out, it's actually 1 million. So there are 1 million centimeters cubed in 1 meters cubed. Okay, so what you need to do is, so that means what you need to realize is that, well, 1 meters cubed equals 1 million centimeters cubed. Okay, so what I'm going to have to do is I'm going to have to say, well, 1.02 times 10 to the 19 divided by 1,000,000, and I'm going to write this in standard form, and that'll give me in 1 centimeters cubed. But then I've got to times it by 500 centimeters cubed to give me number of molecules in 500 centimeters cubed. Okay, and when I work that out, so in 500 centimeters cubed equals 5.1, that's what I'm getting on the calculator, times 10 to the 15. That's what I'm getting on the calculator. But you've got to be careful, okay? Because we need to give it appropriate significant figures. Now, appropriate significant figures, how do you decide appropriate significant figures? And this is where I'm going to talk about appropriate significant figures. The way to decide, and I've told my students this, I think all of you need to be aware is, what is appropriate significant figures is look in the question, okay? What kind of significant figures are they giving you in the question, you know, in the actual figures that they've given you in the question. So here, look, 1, 2, 3, 3 sig fig, okay? 1, 2, 3, 3 sig fig, 3 sig fig. And even here, do you remember I said, it's actually, Avogadro's number is actually 6.022, but they're deliberately giving you 6.02 because they're trying to tell you, listen, you need to give me the answer in 3 sig fig. All right, so 1, 2, 3. So the answer should be in 3 sig fig. So even though my calculator at the end says 5.1 times 10 to the minus 15, students will, what they will often do is they'll just put 5.1 times 10 to the 15, end of story. Or unless they realize appropriate sig fig means 3. So I've got to put a 0 there to give me the appropriate significant figures. And that's the number of molecules in 500 centimeters cubed. Okay? Now, a number of other things, what students do, you know, where do they go wrong in this particular question? One of the common things that they do is this, and I've seen them. This is not wrong, but I think it wastes a lot of time. When you actually do that on the calculator, you'll get sort of 1,000,000 digits on the calculator, right? Because it won't be in standard form. And what students end up doing is they start writing down all the units from the calculator, okay? Now, I know some teachers said, okay, well, look, whatever you get the answer on the calculator, just keep using those and keep working out on the calculator. You can do that, but you've got to show you're working. Remember I said to you, you've got to show you're working just in case you make a silly mistake. So if you keep using all the numbers in the calculator for each of the steps, because you're doing all the calculation on the calculator, it's very easy, isn't it? Answer times next step, answer times next step, yeah? To use all the figures, that's very easy. But then trying to write those numbers down will waste time. So the best practice in chemistry is, if they say use appropriate significant figures, and I'd argue that even if they don't, look in the question what kind of sig fig they're using, precision they're using, and use that precision throughout the question. Okay, so that's why, I did say to you, I'll explain it later, that's why I use 3 sig fig here in the middle of the question. Any calculation in the middle of the question, use the appropriate number of sig fig that you need for the answer. How do you find that appropriateness? You find it from the question. And even within the question, I'm going to use 3 sig fig, 3 sig fig. You can use one more, I suppose, okay, but definitely don't use less. So if I here started using 1.7, here I started using 6 times, here I started using 1 times, that will introduce errors in the precision, which means that you will not get the final mark. Okay, so in terms of sort of wherever it says significant figures, please, either, my suggestion is top priority, use the correct significant figures that you're going to need for the answer throughout, okay, the question. All right, and then of course show you're working with that correct significant figures. All right, if you are going to use sort of the full numbers shown on the calculator, you'll still probably get the right answer, but my worry is you'll be wasting time because you've got to show the working out, so you'll be writing out 10 digits every time. All right, so my suggestion is don't even do that. All right, and definitely do not use less significant figures than what you need at the answer, in the answer. So if I need 3 sig fig in the answer, I definitely don't want to use 2 or 1 here throughout the question. Okay, so that's one of the things, the questions that, this is one of the places where students go wrong. So the other place where they often go wrong, and this is a common mistake in this particular question, is where they forget to change the kilograms, to work out moles, right? They forget to change the mass from kilograms to grams. And now what that means is that they will, lose that mark. Okay, so they'll lose, they will lose this mark here. Obviously, I'm going to give myself a mark, but they will lose this mark because they've not changed the kilograms. Okay. However, then they will get what we call error carried forward. So they will probably get, a mark here and a here and one here, assuming they've not made any mistakes here. Okay. So 1 mark is for that. Number of molecules, in 100 meters cubed, they'll probably get 1 mark for that as well. And then the last mark is here. Okay. So it's a quick one. Okay. My request, I know a few of you do watch my videos, okay? It would help me and it would help your sort of peers, your colleagues, if you can actually, like my videos, subscribe to them, sure, subscribe to them, definitely like them, subscribe, and also maybe leave a comment. The reason how it will help the peers, your other friends and friends, for example, is next time when they're searching for a question on freons or this physical chemistry type question, YouTube, if I've got lots of likes, they're much more likely to recommend this video to your friends. Okay, so I'd appreciate it if you sort of give me a thumbs up, so like it, definitely subscribe to it. The bell icon, if you want to tick it, fine. Otherwise, every Tuesday at 5 o'clock a new video comes up. And certainly share. Yeah, share these videos to your other students as well. To your other friends. Yeah, anyone else you think might find it useful. So please do that. It'll help me as well, because I tell you what, this YouTube is a very sort of a strange medium. Okay, if I was in a class, I could probably tell from the students' faces, right? Whether they're understanding it or not. If they're not understanding it, then maybe I should approach something different. But here, there's no way for me, to find out whether you're understanding it, whether you're liking what I'm doing or not. Okay, unless you tell me, so either through the comments or liking it or thumbs up or subscribing it or telling me, as some students are obviously doing, what kind of questions you want me to go over. Okay, so please, if you've not subscribed, subscribe, like these videos, and bell icon, share it, and leave a comment, even if it's to say, well, thank you, or actually I like that, or I don't like it, actually could you just explain that part, I didn't understand that. Give me some feedback so I know that what I'm doing is useful. All right, that's my request. I'll see you next Tuesday. Bye.